So yeah. So let me talk a little bit about these references. And the reason I thought about it is because I got this issue. HS load fails when the attribute has type reference. And references, object references, are something that we supported for a long time in HSDS. But somehow, it didn't occur to me this issue of HS loading an HDF5 file and converting it to an HSDS domain. So if you're not familiar with references, maybe now would be a good time we can look at a HDF lab example. So let me go there, and then along the way I can explain how this issue came out. So here, so I created that's the groups, this guy. So I created this notebook example, and like most of our tutorial examples, you can switch between H5Py and the H5 library and H5PyD and HSDS. So let's try just with H5 library. So I'll set use H5Py to 1. And so we import H5Py. Is this large enough for everyone to read, or should I make it larger?
It will be good if you make it a little bit larger, but it's readable, readable.
Right. Here, let me.
It all depends how big your screen is. Our screen is.
My screen's pretty small, so
Mine's big, so I can read it. Yeah.
Yeah. Here, one second. Let me close some of these tabs, make it less confusing. Okay, and then make this bigger. And also, if I close this, that'll help. Okay, how's that?
Better. Thank you.
So we get a directory and we create a file, h5py.file file name, and W means we'll overwrite any existing file of that name to create a new file. And now I'm going to just create a data set. So I get a list of numbers between 0 and 10, and I say f.create dataset, call it dataset1 with this data. So we print that. Very good. And if I call dataset, here, let me clear the other guys. If I get the ID, we know it's H5Py and H5 library because the IDs are these long integers. Okay, so here's where the object reference part comes in. If you say dataset.ref, you return a reference. Okay, and it's opaque. You don't really see anything other than it's an object reference. But what I can do with it, if I pass it to my handle, and here I'm getting a data set, and then dot means get all the values from that data set. We see our original data set. So that might be handy. Maybe not the most useful thing, but you can imagine circumstances where you want to have a reference and maybe the actual data set depends on some other factors, right? So you have some logic, and that logic returns a reference, and then the users that reference don't need to care about the particular H5 path of that data set. They just have a handle to a reference, and they can do all the things you can do with the data set. Okay, and so let's continue. We'll create a group, and here's another interesting thing is you can actually store references as data. So here I say g1.adders, my attribute collection, and dataset_ref. We'll create an attribute called dataset_ref, and we'll assign it this dataset.reference value. Okie dokie. And now if I grab it again, I get my, oops, I jumped to the wrong screen. If I grab it again, I get that same object reference. And if I use it, I get that same data set that I was referencing. Okay, and again, I can do this ... thing to get all the values of the data set. So you may ask, why do this, right? Why create an attribute that stores a reference to a data set rather than just having a link in a group that points that same data set? And in many ways, they're functionally the same. One difference is that references don't, ironically, don't participate in the HDF reference counting, i.e., if I delete last link to a data set, that data set's deleted. But if I create or delete references to a data set, that doesn't affect the existence of that data set. Okay, and now you can even do something more special. We can create a data set of references. So we create a type, and this is kind of a fluky H5 thing. We say h5pi.special data type ref equals h5pi.reference, right? Because this reference isn't a standard NumPy data type. There's this kind of hook to get these types to these HDF5 reference types. And with that type, I can say g1.create dataset, some refs, have 4 elements, and the data type is my DTRef. Okay, so now I have a data set. It has 4 elements. We didn't actually assign any dataset values, so it's all empty at this point. But here, let's say we'll take the 4th element of that data set and assign it to our dset.ref value. Okay, so ref dataset is the dataset of references. Dataset is an actual ordinary dataset of integers, and dset.ref is a reference to that dataset of integers. We do that. And we see we have our 4 elements. There's a null, a null, a null, a not null, a not null, a null, and a not null. And if I take that 3rd element again, we get our original data set. So again, data sets of references, the actual references don't participate in the HDF5 reference counting. Now, what happens if I actually access something that's not assigned? You would get this null reference. And you can do a test. So here I'm iterating through every element of my reference data set. If it's evaluates to a Boolean true, I can evaluate that reference and print the name of the data set it points to. And if it's Boolean false, we just know it's a null reference. Okay, and finally, there's a thing called region references. So region reference is like a reference that points not to the entire data set, but to some subregion of the data set. And I believe in the HDF library, these regions can be an arbitrary collection of bounding boxes. But in H5Pi, a region is just a simple selection area. So here, my 4-element data set, I'll say get elements 2 to 3 and define this region reference to it. Oops, what did I do wrong? Isn't it DSAT 1? Oh. Small mistake. Okay, and now I have a region reference. And again, I can evaluate that, I believe, by doing this. Okay, so that gets the region reference. And actually, I'm not sure how you get the elements that the region reference points to.
You get selection, that's what the region reference is, right? You can get,
Yeah.
and then you read those elements.
Yeah, I'm not sure how to do that in H5Pi though.
Oh,
How about bracket, parentheses, bracket, or that, maybe?
Like this?
Yeah.
No?
No, huh?
Strange. Okay, sorry, I'll need to look that up. Okay, and finally we can close the file. So I think in this meeting there are people among us who know a lot more about object references than I do. So any comments? Or if I more or less describe how they work?
well, it is interesting that when you kind of resolve the reference, it gives you the whole data set. When you were trying to print the reference, right, there was a line. So it gives you the whole object back, but not a reference, which is really something, right? It is encoded integer. So it's different from what C library does.
Yeah, I wonder, is there's functionality in the H5Pi layer that's doing things a bit differently?
And it's perfectly fine because it's Python. It's different. And does H5Pi support new references that can go to external files?
Yes.
Okay.
Yeah, as well as H5Pi-D. So here, if we do H5 dump, we'll see that we have our data set, we have our subgroup, we have an attribute of data type H5T reference as a scalar, and it points to /dataset1.
John, and to respond to Ken's question, Ken, this 800, it is exactly addressed at the byte 800. There will be header message for dataset 1 object. So H5 dump prints. This is because how it those old references were encoded for objects. It's really object address.
So it's really the offset in the file that is that data set it's referencing.
Yes, but it depends because they were encoded differently. And for example, if you use vol connectors, they become much more complex. So it's only very old references to the objects. They give you address of the header of that object. Yes. But it's just some number that you can use and use library APIs to
access, right? So you shouldn't be thinking about the actual value of the reference. You just use it as a key,
right,
to access other things.
Right.
Understood. I was working on a question where someone wanted to grab their data sets in object creation order, and they didn't create an attribute. You know, they should have put some kind of timestamp on it, right? So they were trying to use that as a proxy for order creation. And I don't think that ID you show there for data sets exposed in the H5Pi, but I did find offset, and that did work. So I don't know if that's reliable because I don't know if the offset changes.
No, it's not reliable because library uses space, and if space was freed and object fits there, it may reuse it. So really,
yeah, that was my conclusion. Like if you created the library or created the file and didn't do anything to it, it would be okay. But if you resized the data set or deleted the data set and added one, you'd probably have the numbers change.
Right. So the best thing is to enable creation order.
Right.
Then
but that gives me an idea, right? You could say, as you're creating these data sets, you have another data set that's storing the order of creation, right? So as you create data sets, you add a reference, you append a reference to this reference data set, and that would keep track of the actual order of the data set creation.
Yep. Yeah. There's a lot of ways to do that, but none of that was planned in advance. So
Yes, right.
Yeah. So those numbers, back to my original question, like that data set 800, that looks like the number that's exposed in HDF view. When you go to the object tab, it shows a number, and I couldn't get the offset to match that. It's some, I don't know, maybe it's the size multiplier between the ints and the data set number or something.
You should put pointer on that number or click on it, and it should give you, it should show the data set. And there was an option that in HDF view that it doesn't print the numbers, it should print you the values, so the object paths that a reference points to.
Yeah, it shows all that. So in view, there's the name of the data set, then the path, and then the, you know, what type it is, and then there's an object reference and just a number. And
Number,
that
right. It's library uses this number to print that information. Yes.
Yeah, but I don't think that's available because I just tried. So one little thing I learned was that data set ID. I don't think that's exposed, right? I got to ID and then got offset, but I didn't have ID.
And ID is not persistent. ID is generated at runtime. So you
I even noticed I have a little test file, and it changes even from the first time I went to get the ID to the second time I went. So it looks like it's generated every time you read the data set.
Right.
Yeah.
But actually, that's an interesting segue. So going back to the notebook, let's switch this to use H5PD and HSDS instead. All right. So we'll come here, import H5PD as H5Pi, get our home folder. And so one thing about HSDS, I was talking to another developer about this yesterday, is in HSDS, there's no concept of a current working directory, right? So when you're talking to the server, you always need to give a full path to the thing you want to create. And so here, the path will be /home/jreadey/HDF lab tutorial/. And we tack on the file name for that. And we create our HSDS domain using that file name. And as before, we'll create a data set. And here's the kind of reference to what you're talking about. If I say dataset.id.id, since now we're talking to HSDS, what I get is actually a UUID for that data set. So unlike the library, the IDs in HSDS are persistent, right? So if you have two handles to two data sets in HSDS, and you compare the IDs, and they're the same data set, right? And I don't think that works precisely that way with the H5 library.
Oh, no, it doesn't, at least not in the Python API, it doesn't.
No,
Right.
it's not that different, yes.
Right. And then this plays into how we use references in HSDS. So if I say dataset.reference, so remember with the library, we got this HDF5 object reference opaque thing. And here I get what's actually a string. And so the string says datasets/d blah, blah, blah. So my reference that we use in HSDS are actually just a special string which has a data set, so you know it points to a data set, not a group, and it has a UUID of the data set that's referenced. So, you know, this kind of thing wouldn't work in the library because the integer IDs of data sets, as Elena was saying, will change all the time.
Yeah, and the idea was from the beginning when it was designed that address is permanent of the object. And this is used as a reference, which is, and there was discussion to introduce this UIDs into HDF5, but it was too late. So in some sense, it's a design flaw. Because in 1998, no one was thinking about
and now you see UIDs everywhere, it seems.
Right.
So it's, yeah. So anyway, so we can kind of go along, and it works the same as before. And we'll create a group as before, and we'll save our reference to an attribute, and that's all fine. And again, when I print the attribute, I get the actual string out. And I actually, I think at the time I was thinking, okay, maybe I should have it just print, object reference like the library does, but it was actually helpful for debugging to see, when you do a print and see what that reference was pointing to.
John, question, sorry for the background noise. But if I create through H5ID a reference, will it be this UID? And you will, so when you import your data sets, it has to be rewritten, data should be rewritten, like data set with references. Those have to be rewritten because they would not make sense.
So yeah, so when it's saved into a storage, so attributes are stored as JSON as part of the dataset metadata or group metadata.
Right.
And it'll just be a thing that says, okay, this is the type, H5T reference, and this is the reference value, which will just be the string.
Right, but if you have data set with object references and NPP files, NPOS files, they use object and region references, and they are stored in data sets. When you import those files, then you have to rewrite those data sets. It's data.
Yes, and that actually is going back to the issue that I was talking about in the first part. So yeah, let me continue this, and then I'll illustrate how this problem arose. And I think it's exactly as you're alluding to. So we get this. We can dereference it like that, and again, you can create a data set of references. And one little thing is that this type is even though it says H5Pi, H5Pi reference type, it's not actually H5Pi, it's H5Pi-D reference, which is a different thing, right? It's not the same thing. So when you're converting from HDF5 files to HDF domains, you'll need to switch that type around. So again, we can set the elements, and then that works like you expect, right? So null references are just empty strings, and non-null references are strings of form dataset/UUID. That's fine. And then this same kind of logic of checking for null references works same way. And this, unfortunately, region references are not supported in HSDS. If I do this, I think it's going to fail. Well, I don't know what that's doing, but it's not a region reference, right? Okay, let me close it out. So yeah, going back to this issue, right? So when I do hsload, so hsload is a utility that converts HDF5 files to HSDS domains, right? And if I do hsload on this file, created 13.h5, it's going to say, okay, there's a data set. It's 8-byte little Indian integers, fine. It's 10 elements and has these values, right? That's very easy to translate to the HSDS syntax. And we have a group, right? Now, for the reference, for this attribute reference, one thing is we need to change that type. And the other thing is we don't want to have a reference to a data set in this HDF5 file we want the reference to be the corresponding data set in the HSDS domain. Right? It wouldn't make much sense, right, to have the HSDS domain pointing somehow to some user's file on their laptop. So we had to have that logic. And that's where things went off the rails for the HS load before. So if I do HS load 13.h5, let's do -v for verbose. And then give it a folder. Okay, that actually worked because I installed the new version of the library. Let me, so before, when it got to this reference, it wasn't doing the right thing to convert the reference type and then keep track of if that reference was actually pointing to anything, and if it was, have it point to the new thing, right? So this is working now in h5pyd version 0.13.1. So if you are using references and you want to HS load files with references, you'll want to upgrade to this 0.13.1. Okay, now Elena, was this the issue you were thinking about, or is there something else?
Yeah, because this is really also an issue if you think with when you repack the file, everything will change in the file. I don't remember now if we are rewriting those data sets. I believe not, it's only attributes. So data sets will be nulls or something. Now I don't remember, but in your case, for example, if you use different wall connectors, right, wall arranges HDF5 objects in some other ways. So through your wall APIs, you should be able to make H5 in theory, right, H5 down to work with your wall APIs and display information that is related to your new storage.
Right.
But of course, I don't think it's working this way because there are no, I don't think there are callback functions that will allow you to write how object is displayed. Because in your case, I don't know, if you use H5 dump with REST wall, will it dump in the right way?
I think we never got H5 dump working with the REST file.
You didn't?
I forgot what the issue was, but yeah, that's something we should.
Yeah, but it's a big, it's pretty huge task to make it to work. I know that they made it to work with DEOS, but it was in some sense easier than in yours because DEOS was kind of following data model very closely, where your storage is different now.
Right, and something else I wanted to show is in this release, there's so I only in the last month became aware there's this utility H5 stat.
Come on, John.
No, I realized I just never come across this before, right? I was like, wow, that's pretty cool, right? And so, if you want to see all the details of the file. And I said, well, so I created HS stat. So we can do HS stat now. HS.
Yeah, it's just while you're typing, it's very useful utility when you look at that summary because it lets you know how much metadata you're using in your files versus raw data and how fragmented will be the unused space and so on.
Right. So let's try this. So this is, I think details differ a lot, right? Between the H5 stat and HS stat. But in HS stat, we have the owner. Right. So let me digress one more time here. For HDF5 files, the owner of the file is a POSIX attribute, right? In HSDS domains, you don't care that the server owns the storage that files are into. You want to know which user made the request to HSDS to create the domain in the first place. And that's what the owner is tracking, right? That's the username that first made the request to create this domain. And then the ID is that same kind of format for the UUID of the root group of the domain. Last modified is just a few minutes ago. And last scan is about a minute after that. So what's the scan thing? Well, if you imagine you have like a very large file with maybe hundreds of groups and millions of chunks, in the HSDS file format, each of these chunks is stored as a separate object, right? So it would take some time to iterate through all those objects and tally up how much storage was used. And so it may be so large that you'd be waiting for a few minutes to get that information. So what we do in HSDS is there's a background process that pays attention to recently updated domains, and then runs this kind of aggregation sums in the background. And once that's a result, it saves those results to an easily accessible format. So when I do HSStat, then it's asking the server for the summary information about the domain. And the last scan is the time in which that scan happened, completed. So if you change this file, then the output you get from HSStat won't be necessarily up to date, right? There'll be like a minute or so lag between the current state of the file, assuming it's changing all the time, and what you see in HSStat. Right? And then going on, we have MD5 checksum. So this is a value that will change if any dataset value in the domain changes, if any attribute changes, if a link is added, and so on. Total size is a paltry 2518 bytes. Allocated bytes are a number of bytes that are part of a dataset. Metadata bytes are metadata, 962. Number of objects are number of datasets and groups. And number of chunks is the number of chunks over all the datasets in the domain. Okay, so I don't have some of this other information that would apply in H5 stat, like free space, I suspect is used by the for like a heap storage to store variable length data. We don't have that in HSDS, so variable length types are all stored contiguously as part of the chunks. So I guess over time, though, there'll be more and more information here, and it'll get more complex.
No, free space, it is, it says that we are tracking free space only while file is closed, file is open. When we close, we'll lose this information because there is a setting of the library. So free space persists. When you open, library will not know where that free space is, and free space will be lost.
All right, great. So Robert, did you have a question that I ask you to ask later, or?
No, I don't.
Or was that Ken?
That might have been that Ken. But while I have the mic,
Yes.
when you do the reference translation, that's just done in a subsequent pass after you first create all of the
right,
data
right,
sets.
yeah. You realize, right? Otherwise, there's this problem, right? That you might be referencing a data set that wasn't even created yet, right?
Right,
So
you could have a
first we go
forward
through and
reference.
create all the data sets, and then we go through and create the reference links to those.
Yes, and just one follow up: the region references are not implemented.
They're not. And if if anyone is interested in region reference support in HDS, I'd like to hear it. So it hasn't come up as a popular feature request so far, but I think it's really neat. I feel it's like an underutilized feature of HDF5.
And if you're serving NPP files, then they use it a lot.
Mm-hmm.
But it's doable. It's not there's no real underlying technical issues with it.
Right. And but as I was saying before, and Lena, I think is Quincy signed off?
Yeah, he signed off.
Yeah. I think he told me a few years ago, right, that region references in the library were this Boolean collection of rectangular areas in the data set. But I think in H5Pi, they're actually more simple. They're just basic selections.
Well, but don't they support hyperslab APIs on low level where you can create complex selections?
In the vol level, but as far as the H5Pi API,
not
I
low
don't believe
level,
so.
low level APIs in H5.
Right. Yeah. So I normally just use the high level APIs. So yeah, something I should clarify. H5Pi and H5Pi-D try to be as compatible as possible at the high level, but there's no aim to be compatible at the low level interface.
And the design goal for H5Pi was to be be close to NumPy, right? And NumPy doesn't support those selections.
Right. Yeah, and in general, be more Pythonic, I guess you would say. Right, certain idioms in Python that people expect to have. So, all right, yeah. So I think object reference support would be really nice to have in HSDS, and then I was just that's one of the big gaps we have now between HSDS and the library.
And John, I'm coming with specification of variable length chunk, which will contain first use for storing sparse data. It will be interesting to see how you will specify it for the future, not implementing.
Right. Yeah.
Because this variable chunk idea really works well, for example, with variable to use for storing variable length, because essentially you're storing data, metadata about your data within the chunk, and in the sparse chunk, it will be selection through that chunk. But then you also can store, using the same concept, cell arrays, which are very popular in MATLAB. I don't know if anyone here use cell arrays, and where it will be interesting. But then we will need to kind of, if it's accepted, and moving forward, to spec it for cloud storage.
Okay. Cool. Yeah, and for HSDS, we use a very simple kind of structure for variable length types for chunks, which is for each element, there's a 4-byte integer that says how many bytes in the element, and then another 4-byte integer of how many bytes in the next element, and so on. So that's kind of the persistent storage for that. When we read a chunk of variable length types, it becomes on the server just pointers to objects, as you'd expect.
And this will be then easy because you have this. It is exactly what will be stored in the file. In the chunk.
Great. Okay. Well, any other questions? Okay, I guess not. Okay, well, thanks everyone. Nice talk. And I believe next week, Dana will be here.
Yep.
So look forward to that. All right.
Everyone.
Okay. Good night, everyone.
Enjoy seafood.
Yeah, thank you.
Bye.
Bye-bye.